In this video, we are going to talk about how to output the failure indices from MSC Nastran. Now, the failure indices are output when you use PCOMP or PCOMPG entries. Now, if you look at the quick reference guide, if you go to the PCOMP entry here, if you look under the failure theory field and click on C Remark 7, you'll see that there is a list of values that you need to supply in order to get failure indices. Now, if you're only interested in getting values, or if you're interested in using theories like Hill or SOUTi, the only values you need to provide are A, B, and C. So in this video, I'm going to walk you through how to supply all these values. Now, the starting point is the following. I performed the analysis. I'm looking at the F06 file and I look and see and say, hey, where are the failure indices? I'm not getting any failure indices. So if you look at the remarks, it says under remark 7, in order to get failure index output, the following must be present. A stress or strain command for the PCOMP entry, the shear bonding strength, the failure theory, and the layer output option must be on. Also, the allowables for the layers or apply must be supplied on the MAT8 entry. So here in this video, I'll walk you through how to add all this information. So here, this bulk data file is a starting point. This is currently working. I do get displacements at least, but I'm not getting the failure indices. So we have to modify some of these entries with data that it needs to compute the failure indices. So let's go ahead and do this. Today we are going to be using a web application that's available at theengineeringlab.com. If you go to this website, at the top right hand corner, there's a blue button that gives you a free trial to the pre-post web app. So if you want to follow today's tutorial, you can go ahead and get a free trial of that. So you go to the home page of this web application. Let's maybe go there right now. You would go to the viewer link here on the right, and that will take you to this web application. Let's go ahead and click on file upload and upload that model that's not working today. So we get displacements, but we're not getting failure indices. So if we look at the list, the first thing it says, you need to add the stress command. So to do this, we'll open the pre panel here on the left, and we'll click on the case control command section here on the right, top bar rather. Once you're here, click on commands. In this table, look for the stress command and assign it to a subcase. Here it will say add this to subcase, to the above subcase. Go to configure, and then you could make some modifications there, but I think the default's enough. Here on the top right, if we look at this, we see that the stress command is on. So let's do this actually. Let me move this to a text file. And let's make a checklist here. So for A, we're done with that. We did add the stress command. Now for the PCOMP, we have to add a shear bond strength and failure theory and SOUTi. Okay, so let's go ahead and modify the PCOMP entries. So to do this, go to the bulk data section, look for PCOMP in the table, click open. And then here, if you scroll to the right a little, if you click on display descriptions, this will tell you what each value does. Here, the SB column, that's going to be the shear bonding strength, if you will. This is something that we forgot to add, and we have to add. That's one of the requirements here as told in the remark. So what is SB? If I look at the other version that I have, the SB value is provided in this older example that I have. So I'm just going to copy and paste that here. And notice that that field has been updated for us on the right. So if you look at field 5, it now says 90E6. For the failure theory, we are going to select Hill. Now for the SOUTi output, this basically controls the output for each layer. So if you look at this table with all the different layers, let's go ahead and maybe modify some of these materials here. Let's go ahead and see what we have here. I'll just use 0 for today. I noticed some of these layers were blank, so I was just populating those. So here in this column, SOUTi, if you hover over the description, that's going to give you the full description like you see here on the screen. This is going to tell Nastran to output stresses or failure indices for that layer. Here we'll say for layers 1, 2, 4, and so on, yes, output the stresses or the strains or the failure indices. You can go row by row, or you can use this one top row and this button, and you can make modifications to every row with just this one box. So you have a few options there. Okay, so did I add a shear bonding strength? Yes. Did I specify a failure theory? Yes, it was a hill. And did I specify SOUTi? Yes, I did. So we're done with B. Now, what about C? Here we have to define what the allowables are for each layer. So what's allowable along the one direction for tension and compression? Same thing for the layer's second or axes. What's allowable for tension and compression? And then the shear strength value, or letter S. So to do this, let's go ahead and go to MAT8, which defines the orthotropic material. And here you'll notice if we scroll to the right, we start seeing the columns for the allowables. So allowable along the X for tension and compression, allowable along the Y or the second axis for tension and compression, and then an allowable for in-plane shear. So here we have to supply these values. You'll notice that they're all blank. That's part of the reason why we do not get failure indices. So I'll go back to an original example that I have. I'll just copy the values here because I already have them available. So let's go ahead and copy the allowables here, here, and here. And remember, there is a free trial of this web app available, so you can visit theengineeringlab.com. Fill out the free trial form, and then we'll go ahead and send you a link to a free trial of this tool. Okay, so you can see in fields 5, 6, 7, 8, and 9 here on the right, we specify the allowables for the 1 and 2 axes and tension and compression, and then we specified a shear strength. So now we satisfied the third condition to get failure indices. So now what's there left to do? If we go to download, we'll go ahead and click upload PDF and immediately run. And let me redo that again. And then this is going to open after the analysis is completed. This is going to open a plot of the deformations and stresses, but we don't want to look at that right now. If you go to the results, if you go to F06, and if you look here, you can see that we now have failure indices output in the F06 file. And if I go here, let's go ahead and turn some of this data off. If I go to the post panel, I can actually access this dataset, failure index dataset. Select this checkbox, and let's go ahead and select the layer. So here are the failure indices for the first layer, then the second layer, the third layer, fourth layer, fifth, so on and so on. You can select all the layers. Here, let's go and select layer 1, hold the shift key, click the last layer, and then all the layers are selected. This is going to determine the layer with the highest failure index. Here we see that for layer 15, the highest failure index is 0.089, and this happens to be occurring in element ID 154. And then what's the lowest failure index? It's 0. It's happening in layer 1 and element 141. And here maybe we can confirm this with the F06 file. So if you go to the pre-web app, scroll down to files on remote system, you can click on download F06. And then here, let's go ahead and open this new F06 file. And what we want to confirm is the maximum value. So here we're being told that in element 154 in layer 15, that's where the highest failure index is happening. So let's go ahead and see if we can track down that element. And there is a lot of data. Here, let's go down to element 156, I believe it was. Oh, 154, sorry. So let's go to 154. So here we have element 154. Notice that this is a table. This is a table. This is column 1. So all these values are for element 154. This is another column that specifies the failure theory for which these values are corresponding to. We have a layer number. This is layer 1, layer 2. Alternatively, these are ply 1, ply 2, and so on and so on. We have a failure index for the layer, and then a failure index for the adhesive if there was one. And then here we have a failure index for all the layers for that one element. So here we see that the max failure index for all plies. Interesting. Am I reading this correctly? Oh, interesting. Anyways, we'll look here and we see that element ID 154, layer 15. So let's go ahead and find layer 15. Here it is. 0.0891 is the largest failure index that we have here. And let me look at this for a quick moment. Failure index for all elements, max of FP. Oh, interesting. I think there might be... That's okay. I won't worry about too much about what this value is. Here it's telling me it's the maximum value, but if we look here at all these values, the maximum value is 0.0891, but here it's saying that the maximum value is 0.0062, so that's kind of odd. It would take me too long to figure out why this is being reported like this, but maybe I'll skip that for now. Okay, now that is how you output the failure indices. So remember, you want to make sure that you added a stress or strain case control command. The way we did that was we went to the pre-panel, we went to case control, we selected the stress out command, we went to configure. We really didn't do anything, so we were done with the stress command. Then we had to update the PCOMP entries. So we went to the bulk data section. We went ahead and found the PCOMP entry. We specified a shear bonding strength, a Hill failure theory, and then for each layer we specified, yes, we want to output the stresses or the strains, which will also output the failure indices. And then after that, we have to make sure that the MAT8 entry had the allowables defined. So here we define allowables for the 1 and 2 axes for tension and compression, and then an allowable shear strength for the layer. So that would be the S column. Once we had all of this, we then were able to output the failure indices to the F06 file, the OP2 file, and the H5 file. Now, when you do this, you'll notice that, and that's pretty much the end of this video. This is a bonus part that I'm adding now. You notice that the F06 file has a lot of data. It has data for each element, for each layer. Sometimes you want to control this. Here we know that the highest failure index happens in element 154. So we can tell Nastran, you know what? For element 154, output data just for element 154. So that's what we'll do here. We'll say create another set command here. And we'll click on the pick icon. We'll select 2D elements. And here we'll go ahead and we'll make the picking sphere a little smaller. we'll say pick these elements here. These are the elements we want our failure indices for. So that would be, let's go and see what elements they are. Element 153, 154 through 158. So now when I go to case control, configure, for the stress, it's currently set to output data for all the elements. But here I'm going to say, you know what? Use that set command we defined a moment ago. Output data only for those element IDs that we've selected a moment ago. Let's go ahead and rerun this. And then let's go back to the pre-web app. If you look at the result files for the F06, you'll notice that now we only get data for elements 154, 155, 156, 157, 158. So those would be the elements we selected a moment ago. Let me double check that. All right, so element 153, let's make sure that was in there. Oh yeah, it was here. So this is the table for element 153. These are the failure indices for element 153. Now, we can modify this list here if we wanted to. We could say, okay, forget about all those other element IDs. Just do this for element 154. And let's go ahead and make sure we're selecting this command, set to. So that would be this 2. So set ID 2. We've made the adjustment. Now I can go here and click and run. And if we look at the F06 file now, we are only going to get failure indices for element 154. So here are the stresses for element 154, and then the failure indices for element 154. Now, when you do this, when you look at the failure indices, go ahead and turn that off. Go and select the failure index data set. Since we only have data for element 154, we only have enough data for element 154. So all the other elements are going to be gray in color because we don't have that data. We did not output that data. This is true for the failure index and the stress. So if we look at the stress for, I don't know, maybe a layer 10, you notice again, we have data for element 154. We do not have any other data. So that's why the other elements are colored gray. So keep that in mind if you ever use the set command. Okay, so going back to the original goal, how do we output these failure indices? That was the goal. We ended up finding out from the documentation that we needed at least 3 things. We needed the stress command. We needed to specify additional values on the PCOMP entry. On the MAT8 entry, we also needed to specify additional values. Once we satisfied these 3 conditions, then we started getting these failure indices. Now, if you're using some of the Hashine failure theories, there are some additional requirements that you have to meet in order to get the failure indices. So that would be letters D, E, F, G, and H. So if you're using Hashine, make sure you satisfy these other conditions. But if you're using some of the other failure theories, for the most part, you have to worry about condition A or requirement A, B, and C. If you satisfy these 3 conditions, you are going to get failure indices like you saw in this video. Okay then, so one other thing, let me see if I can find it. I'll say this, in total there are 3 video tutorials for composites. In the first tutorial, we go over how to define a PCOMP entry. In the second tutorial, we talk about how to define the 0 degree direction of the laminate. So that's something very important. When it comes to laminates, you have to define, okay, the direction of the 0 degree axis, where is that going? And then if you want failure indices, how to output failure indices. So this video that we saw is video number 3 in a 3-part series. So if you're interested in viewing the other videos, you can go to the engineering lab. We have a YouTube channel. So let me see if I can find it. So here's the engineering lab, the YouTube channel rather for the lab. If you go to videos and start looking for PCOMP, you will be able to find those videos. I'll also mention, maybe in the video link below, I'll add links to these other 3 tutorials that we have. So here's the first one, how to configure the PCOMP entry. Later today, I'm going to upload the second, and I'm going to upload this 3rd video on how to output failure indices for the PCOMP entry. Okay, so that's pretty much the end of the video. As a last reminder, if you want access to this web application, you can visit theengineeringlab.com. Top right hand corner, there's a link to the free trial. Click that link, fill out the form, and we'll go ahead and get you started with the free trial. So that's the end of the video. As always, thank you for watching, and thanks.